Hey y'all, in this video we're going to go over the notes for work and power. So first up is work. In physics, we define work as a force acting upon an object to cause displacement. Basically what that means is that work happens when there's a force that moves an object, right? So there has to be, the object has to move for work to be done. So if you push on something and it doesn't move, then no work's being done. And the force has to be what causes the movement. Like if you're carrying something and walking, there's a force applied to what you're carrying, but that's separate than you moving forward. All right. Like the force and you moving forward are two separate like things going on. Right. It's different than like if you're pushing on a cart at the store that you're moving forward with, like as you're pushing the cart. Okay. All right, so let's go through some examples of this. A student applies the force to a wall and becomes exhausted. There's no work being done there because the wall's not moving, all right? There's a force but no movement. All right, number two, a calculator falls off a table and free falls to the ground. There is work being done because of the force of gravity causing that calculator to move to the ground, all right? The force of gravity is what's pulling it to the ground, right? Number three, a waiter carries a tray full of beverages above his head and walks across the room. There's no work being done to the tray in this case because while he's moving forward, the force that he's applying to the tray is separate from him moving forward, right? So there's no work being done, right? And then the last one, a rocket accelerates through space. There's work being done because of the engine is what's propelling that rocket forward. So the force of that the engine's applying is what's moving it forward. So basically, to sum it up, if there's movement, that's let me rephrase that. If there's no movement, there's automatically no work. If something is being carried, like this waiter carrying a tray, or if you're carrying a book or a backpack or a suitcase, then there's no work being done on what's carried because it just becomes like a part of the person, right? An extension of them. And then if the force is what's causing that movement, like the calculator falling or the rocket or you pushing on like a box across the room, then there's work being done, right? So work and energy are related. When work is done on a system, that system's change in energy equals the amount of work being done. Therefore, work and energy will have the same units, which is joules, which is abbreviated as capital J. So let's get to the formula now. The formula for work is work equals force times distance times cosine of your angle. And make sure your calculator is in degree mode when you're using this formula. So just to show you here what things mean, F is for force, of course. It's measured in newtons. It's what causes the displacement. D is your displacement or distance, and it's measured in meters. And then theta is your angle between the force and displacement. So we won't really work with these diagrams, but just to show you where this theta comes from. Like if this is our box and say this is like a rope that we're pulling on it, this is the angle we'd want here. It's a difference between like say the ground and the angle the force is being applied at. And then the reason for using cosine in here is that we only care about how much of that force is moving it across the floor. We don't care how much of it is lifting it up, like the Fy. We don't care about that. We just want Fx, or the horizontal component of the force. So that's why we have the cosine in there, right? So let's go through a couple examples. The first one is how much work is being done on a vacuum cleaner pulled 3 meters by a force of 50 newtons at an angle of 30 degrees above the horizontal. So the person vacuuming is holding it actually pretty low to the ground, right? So we're going to use our formula and plug in what we know. So we know our force given to us was 50 newtons, our displacement or distance was 3 meters, and then our angle was 30. We want to make sure you're in, again, degree mode in your calculator, not radians. You'll type that in and you should end up with 130 joules. All right, easy enough. For the second example, we have how much work is done by pushing a car 2 meters by a force of 40 newtons in the direction of motion. So here the key thing we care about here is this direction of motion. What that phrase means, or any similar phrasing to that, means that our angle is going to be 0. So it says that you're pushing straight on in the direction that object's moving. Right? They're parallel together. So your angle is 0, right? So your formula here, you're going to plug in, of course, the 40 newtons, the displacement of 2, and then your angle is 0. Cosine 0, if you type just that into your calculator, you'll see it and equals 1. So technically, if you really want to do it, you can leave that out and just multiply the other two numbers. But When you do that, you're going to get 80 as an answer. So you can type the whole thing in, or if you know that says, hey, it says direction of motion, I can just do the first part. You can do that too. But know that anytime you see direction of motion, your angle is going to be 0. All right. Next thing is power, which is really easy too. Power is the rate at which work is done. It's it's technically a ratio of work over time. So the formula, real easy one, is power equals work divided by time. So a lot of times on like tests and quizzes, this will be set up as you'll solve for the work, and then the next question will ask you to solve for the power of it. So you're simply going to divide the two. The unit for power is a new one. It's watts, just like when you like if you ever bought light bulbs for your house, it's measured in watts normally. So that's the unit for it. So let's work through an example. So how much power is used if the work is 500 joules for 15 seconds? We're going to just plug that in of work of 500, divide that by 15. We type that in the calculator and we'll get 33.3 watts, right? So that's a really easy formula to work with. I think you won't have any problems with that. But if you guys have any questions, feel free to reach out.